In this video of the Parkour series I will cover roll, dodge, and air dash. The player can roll while moving and if idle. The roll amount is different based on if moving or not. The animation is also different if sprinting and rolling. If the player rolls while in air, if close to the ground they will play a land and roll animation. The rolling system adjusts the capsule height so you can roll under objects. If rolled under an object and there is an object above, the player will crouch until there is space. The player will immediately rotate to face the target roll direction. The player can dodge in the input direction. If no input then will dodge forward. Similar to the roll, the player will face the input direction for dodging too. If you press the dodge input while in air, the player will air dash instead. This comes with a trail effect on the hands and feet. The player also leans for procedural animation which makes it more realistic. The dodge and dash system can be adjusted to be directional as well. For this, the dodge will play either in forward, back, left or right while the player is facing front. The same applies for dashing. The leaning is based on the input direction. Finally, the system can be combined with previous mechanics made in the Parkour series. The player can go from air dash to wall running or sliding. It works with double jumping as well. The player can also go from air dash to wall climbing. First we will get an I will speed this part up since you can animate it how you want. Mine will move position and flash red while fading in and out. Go to the graph. For the pre-construct, we will get the text and set text. For the text, get to text string. Append a string for this. Promote A to a variable called RDD type. Compile and set instance editable and expose on spawn to true, then set the default value to roll. Set B to cooldown with a space at the start. This allows us to set the text dynamically based on if we tried to roll, dodge or dash. For the event construct, play the cooldown animation. Then get event on animation finished and remove on parent for it to destroy the widget. We don't need to check what animation finished since there is only one. Next, make an enumeration called RDD state enum. It will have 4 values called none, roll, dodge, and air dash. Next we will make the trail particle. Make a new Niagara system and select new system from selected emitters. Add the simple sprite burst one. First delete the sprite renderer and replace it with a ribbon renderer. This allows for the particle to act as a trail. Then click on emitter state and change the life cycle mode to system. Add a new module on emitter update which will be spawn rate. Change it to 250. Finally click on initialize particle. In the left, add a new float user parameter called lifetime with a default value of 0.1. Click and drag this onto the lifetime. to the negative value of the b you chose for the half height. For the a vector you can break it and set z to the negative of the default capsule height variable. We are changing the mesh location as well since the capsule height scales from the center, so the mesh will go through the ground if we don't move it up to adjust. Now make another custom event called RDD capsule revert and duplicate the previous timeline for it, renaming it to reset capsule. Copy the capsule component and mesh code from the previous event for this. A for the capsule half height should be the current one and b is the default one. Set the alpha to the new timeline's value. For the mesh location, a should be the mesh's current relative location. For b, split the pin and set z to the default capsule height multiplied by -1. Make another event called Cooldown timer. Add a retriggerable delay with the duration being an input. Retriggerable delays will restart if called while already in progress. This is not 100% required here but is safer to use to prevent any possible bugs. Make a new variable called RDD state with the type being the RDD state enum we made. I will make a new category for variables made in this video. Set it to none on the delay completed. Make a new vector variable called RDMoveDirection and set it to default. Finally, make a Boolean variable called canRDD. Set the default value to true and set it to true in the event as well. I will set the default value of the duration input to 2, but you can adjust this to your liking. Now we will do the roll event. Make a new custom event for it. Add a retriggerable delay with a duration of 0.05. Then add a branch that checks if falling. If true, we will check if we are close to the ground for land to roll. Add a capsule trace by channel. The start is the actor location and subtract a vector for the end. Set the z value to 120. For the radius, get the capsule component's radius. The half height I will set as 20. I will promote the draw debug type to a variable so I can change it later when testing if needed. Add a branch using the return value. If true, set RDD speed because the transition should be faster for leaning if the player landed as opposed to blending it out slowly as the player falls for longer. Rename the variable in the character blueprint to dash rotator alpha speed. Now make a custom event called reset air dash. Make a new Boolean variable called landed after air dash and set the default value to true. Set it to true in the event. Then get each dash trail and connect it to a deactivate node. Then set RDD state to none. Get the meshes anim instance and cast to the animation blueprint. Set the dash rotator alpha to 0. This bypasses the finterp and immediately removes the rotation. Then set the dash rotator alpha speed to 5. This event will be used to reset the variables once air dash is completed either by landing or timeout. Next make an event called air dash landed. Add a branch that checks if RDD state is equal to air dashing. If true, set the character movement's velocity. Set it to the velocity divided by a float of 1.5. This is to prevent sliding since without it the player will slide once landed after dashing. Then call reset air dash. If the branch was false, connect it straight to reset air dash. Call this event in event on landed. Next make a function called dodge-get direction. It will have one Boolean input called select condition. Get the actor forward vector and a select vector with it. Then get the follow camera and get its world rotation. Split the struct pin and make a rotator with only the yaw component. Get the forward vector of this for the select vectors B. We are making this rotation so that it is the same regardless of if we are looking straight or down on the player. The condition is the input. Make rot from X of the vector and add a select rotator. For B add the get input direction function. For the condition, get last movement input vector and check if it is nearly 0. Finally get the forward vector and normalize it. Add a return node and drag the normalized vector to it to make it an output. Rename it direction. This function is used to find the dodge and dash direction based on a customizable value. The next function will be called -rotator get value. This one will have three float inputs called rotation amount, move direction, and default value. The default value of rotation amount will be 20. Add a return node and a float input called return value. Set it to a select float and A will be the default value input. Now get the move direction input and check if it is less than 0. Make this the condition for a select float. A will be the negative value of rotation amount and B is the positive. The ABS is not absolutely necessary here but just included to prevent bugs if you enter a negative value for the rotation amount input. Add another select float, with B being the rotation amount. Promote the condition to a variable called -face camera. This variable is a customizable which decides if the player faces to rotate the direction they dashed in. Then multiply the float. Get the move direction input and nearly equal. Get a not operator of this and set this as the value to multiply. It will automatically convert the pin to a boolean when you drag it in. Set the multiplied value as B of the original select node. Now check if the last movement input vector is nearly 0 and add an OR operator. The second condition is -face camera not. Set this as the select floats condition. We will now do the event. Make a new custom event called dodge-event. Add a retriggerable delay of duration 0.05 and add a branch that checks if falling. If false, set can RDD to false and set RDD state to dodging. Then set RDD move direction to the dodge-get direction function. Make sure to set it to a pure function. The condition should be a new Boolean variable called dodge-face camera. This does the same as the -face camera but and invalidate RDD move handle. This is why we added the stop dodge moving montage notify in the dodge montages so the player stops moving once the landing occurs. I will set the default value of it to 1200 but you can use any. Then set landed after air dash to false and add a sequence. In then 0, activate all the trail particles. In then 1, set timer by event with time being 0.01 and looping being true. Set the return value to RDD move handle. Add a custom event for the timer called air-timer. Set the character movement's velocity to the current one's x and y with z being 0. This makes it so gravity does not affect the player while air dashing occurs. You can change the z value if you want them to drop during it. After setting the handle, add a sequence if then 0 being a retriggerable delay. Promote the duration to a variable called air-max time. I will give it a default value of 0.15. On completed, set orient rotation to movement back to true. Then add a branch that checks if the handle is a valid timer and clears and invalidates it if true. In then one of the sequence, add a retriggerable delay with a duration of 1. On completed, add a branch that checks if RDD state is equal to air dashing. If true, set it back to none and set the dash rotator alpha speed to 1. This makes it so that the dash leaning is slowly reset the longer the player falls. I will now comment the event. Now we will do the input event. I will use the Q key for dodging and dashing. On pressed, add a branch that checks can RDD. If true, call the dodge dash event. If false, create the RDD timer UI. For the RDD type, add a select string with the condition being is falling. A will be air dash and B will be dodging. Next, add the widget to the viewport. The final part will be adding the dash leaning rotation in the animation blueprint. Go to the anim graph. Add a transform bone at the end and remove location and scale as pins. Change the rotation mode to add to existing. Set the bone to spine _01. The alpha will be dash rotator alpha and the rotation is dash rotator. Duplicate the transform bone and change the bone to thigh_L. Add the alpha and invert the dash rotator. Duplicate the transform bone for thigh_R and connect the inverted rotator to both rotations. Duplicate it once more with the bone being calf_L. For the rotation, split the dash rotator and make a rotator. Multiply x by 1.2 and z by 2 for it, with y being the same. This is the rotation. Duplicate it one last time for cap_R and set the rotation. Connect this to the final output. Finally, go to the character blueprint and uncheck Auto Activate for all the trail particles so they are disabled by default. I will now quickly make a test map. You can skip to the time shown for the final result and Parkour integration section. The player can roll under obstacles. If there is an object above them, the player will be crouched when rolling ends. If sprinting, the player plays the sprinting roll animation. The player rotates to face the direction they roll in. The player also rotates to face the movement direction when dodging. If you dodge before the cooldown, the widget pops up. Dashing also works. You can easily change the trail color in the particles in the character blueprint. I will increase the opacity to make it more visible. I will also enable dash and dodge face camera to showcase them. The player now faces the camera direction when dodging and plays the directional animation instead. The same happens for air dashing. The leaning is based on the dash direction and is more visible when you dash in each direction. This also works with the double jump system made in the previous video. That is all for the main tutorial. I will now show how to integrate it with the rest of the Parkour series if you have followed along for them. If not, then thanks for watching. First go to the sliding graph. Set A in this lerp for the capsule half height to the default capsule half height variable we made. Then go to the sprinting graph. Make some space before the play montage and add a branch with it connecting to true. Get the meshes anim instance. Check not of is any montage playing and add an operator. For the second condition, get is falling not. This is the branches condition. This stops the stop animation playing if you sprint to roll but release the sprint input while the roll is playing. Next will be wall running and wall jumping changes. Call the reset air dash event after both paths in the on component hit. This allows the player to dash again if they dash then wall run or slide, as currently it only resets once they land. Call the event in the wall climbing graph when wall climb starts as well. Finally go to the jump landed event from the previous video. Add a branch after this one that checks if RDD state is equal to none. This stops the landing animation playing if the player lands to roll. That is all the changes. The player can now air dash to wall run, then wall jump, double jump, and air dash once more. It resets each time the player wall runs so it can be used to create some interesting level designs. The player can also go from air dash to wall climbing. That is all for this video. You can purchase this project using the link in the description if you want. If you enjoyed, Like and subscribe for more content. Thanks for watching.